Okay, so here we are, semester 1 final review. If you are doing this just as to make sure you got the right answers, that's fine. All you need to do then is to go ahead and just fast forward through it. You can even hit mute. You don't have to listen to my voice. I won't be offended. So just go through it, and I'm going to talk my way through each of the problems. If you still have problems, I still have Monday in class to go through this and ask me anything. So, let's get going. So the first one we have are these are called segment addition postulate problems, and that's because they require you to use the segment addition postulate. Segment addition postulate says that if you have a line segment, think of it like a stick, and you break it into smaller parts, that all the smaller parts add up to the big part. So this is how you do it. If we have, hold on just a second. Let me get rid of that. That was my snake crawling across the screen. Okay. So if we have EF plus FG, we get EG. Then we just go ahead and plug everything in. That's going to give us x plus 7 plus x plus 5 equals 12. So then what we want to do is we want to combine our x's. So we get 2x plus 12 equals 12. We are going to subtract 12 from both sides, and then we get 2x equals 0. We divide by 2 on both sides, and we get x equals 0. Now, we're asked to find EF. And I know a lot of you, right off the bat, are going to go, hold on a second, x can't be 0, we're talking about distance. Now here's the thing, x is totally okay to be 0 or a negative number. What can't be a negative number is the actual distance, the length of a side, the measure of an angle, something like that. So that's important because we're going to have a lot of negative x's or x equals 0 here. So EF equals x plus 7. We're going to take that 0, plug it in right there, so we get EF equals 7. And that's it. You could also go back, I go back and check in just a minute. So we have KL plus LM equals KM. And that should make sense to you guys, just looking at it. The distance from K to L plus the distance from L to M is equal to the distance from K to M. So we plug our variables in, or our lengths in. 2 plus x plus 6 equals 2x plus 8. That's going to give us x plus 8 equals 2x plus 8. Subtract x from both sides, we get 8 equals x plus 8. Subtract 8 from both sides, breathe, we get x equals 0. Now, we're being asked to find LM. We know that LM equals x plus 6. We're going to take that 0, plug it in right there, we get LM equals 6. Now if I wanted to, I can go plug in, let's look back at number 1. To check my work, what I do is I'd also find the length of FG. I know that F plus G, 0 plus 5, is 5. So that gives me EF is 7, FG is 5, 7 plus 5 is 12. I know that E to G is 12, so we're good to go. And that's how you check. So, moving on. We now have ST. So that's that first one, x plus 2. Let's set it up first. ST plus TU equals SU. Plug in our lengths. We get x plus 2 plus 8 equals 2x plus 5. ST is x plus 2, TU is 8, SU is 2x plus 5. Want to subtract x from both sides? We get then 10 equals x plus 5. We're going to subtract 5 from both sides, and we get 5 equals x. Then we know that ST equals x plus 2. So we're going to plug a 5 in right there for the x, and we get ST equals 7. Number 4, IJ plus JK equals IK. Then what we want to do is we want to plug in our lengths. X plus 3 plus 2 equals 2x. X plus 5 equals 2x. Subtract x from both sides. We get 5 equals x. So we're looking for ik, that's the big one. So 2 times 5, or 10, because we know that 2 times 5 is 10. Okay, now moving on. Now these are ones that people tend to have a lot of difficulty with. Now I think most of the difficulty with is thinking that somehow the order in which the question words the angles has something to do with how we set them up in the actual problem. It doesn't. What you need to realize here, these are called just like the other ones were the segment addition postulate, this one is the angle addition postulate. So we have 3 angles here. We have KLA, ALM, and KLM. Okay? Now we should know that the measure of KLA plus the measure of ALM equals the measure of KLM. Okay? This is that yellow and blue make green problem. If you're still having difficulty with this, so here's the thing. If you really want to do well on this midterm, okay, or not midterm, but semester 1 final, and you're not sure about something, there is going to be somewhere in my YouTube bank an entire video about each and every one of these things. There's an entire video about the segment addition postulate, and at least 2 about the angle addition postulate, the distance formula and midpoint formula and all that. So even if you're not getting it from this alone, go and check those out if there's really something that you're not understanding. Okay, so once we have that equation set up, we plug in our length. So we get 8x minus 6 plus 4x plus 11 equals 101. Combine like terms, we get 12x plus 5 equals 101. We're then going to subtract 5 from both sides. We're going to get 12x equals 96 divided by 12, and we get x equals 8. Now, we're told that we need to find KLA. Now, we see that KLA is equal to 8x minus 6. So we go 8x minus 6. We know that 8x is 8. That gives us 64 minus 6, or 58. Now, if we plugged in 8 to the other one, we'd get 44. We add, or 43, sorry, we get 43 and 58 add up to 101. We're already told that KLM equals 101, so we know we did it right. If you end up with a wrong x, what happens is when you plug it in, it doesn't work out, okay? So let's say I said 96 divided by 12 is 7, or 9, okay? Let's go to 9. Then that would give me KLA as 72 minus 6, 66. ALM as 36 plus 11, or 47. 47 and 66 add up to 113, not 101. So see, that's how you'd go about and check it. That's why checking work is so important. So number 6. IJK, or the measurement of angle IJB plus the measurement of BJK is congruent or equal to the measurement of IJK. Plug everything in. 13x minus 2 plus 3x minus 5 equals 147. Combine like terms. 16x plus 3 equals 147. Subtract 3. 16x equals 144. We're going to divide by 16. And we get x equals 9. We're looking for IJB, 3x plus 5. So we're going to go 3 times 9 plus 5, 27 plus 5, or 32. Okay, so that's how we got the measure of IJB is 32. Moving on. So now we're at 7. So these 2 are just like the other ones. Want to set up LMQ plus QMN equals LMN. Plug everything in. X plus 31 plus 140 equals 171 plus 2x. Combine like terms. X plus 171 equals 171 plus 2x. Subtract x from both sides. I get 171 equals 171 plus x. Subtract 171 and check it out. X equals 0. Again, we're looking for LMN. So we go 171 plus 2x, 171 plus 2 times 0, 171 plus 0, or 171. And that's your answer. The measure of angle LMN equals 171 degrees. The measure of angle FBC plus the measure of angle ABF is equal to the measure of angle CBA, or ABC as they have it. I'm plugging everything in. That's 17x minus 4 plus 90 equals 6 plus 39x. That gives us 17x plus 94 equals 6 plus 39x. Okay, check these. If you did them and you got something different, check to see where your work went wrong. Subtract 17x from both sides. We get 94 equals 6 plus 22x. Subtract 6. We're going to go 88 equals 22x divided by 22, and we get x equals 4. Looking for ABC, 6 plus 39 times not x, but 4. And that's the measure of angle ABC. So we're then going to go 6 plus 156 equals ABC, or 162. And that's how you do those. So moving on, we then have 9, 10, 11, and 12. Now all of these, look at what it says. It says find the slopes of parallel and perpendicular lines. Now we should know the slopes of parallel lines are equal. The slopes of perpendicular lines are the opposite reciprocal. That means we make sure that we have the slope written as a fraction. We then flip it upside down and change the sign. So let's look at number 9. The slope of our line is negative 3/4. That means parallel lines are also going to have a slope of negative 3/4. Perpendicular lines, we're going to take that negative 3/4, flip it upside down to negative 4/3, and change the sign. So for a line to be perpendicular to a line with a slope of negative 3/4, it must have a slope of positive 4/3. 10. Parallel, same thing, negative 2/5. Perpendicular, positive 5/2. Now here, a little tricky. We're just going to go negative 1 and 1. Because it's just a negative out there, we presume or assume or know, actually, because it's kind of shorthand, that the slope is negative 1. Okay, so we know the slope is negative 1. So when we take negative 1, write it as a fraction, flip it upside down. We still get 1 over 1, but we change the sign. 12, we're going to get negative 3/4 and positive 4/3, just like 9. See? Nifty. Okay, so now these ones. Exterior angle theorem, okay? And that means that the angle on the outside is equal to the sum of the two angles on the inside. So we go exterior angle, sum of remote interior angles, okay? So we go the angle on the outside, 10x plus 17, equals the sum of the angles on the inside. 21 plus 6x plus 40, and then it's just algebra, guys. We're going to combine like terms. We're going to get 10x plus 17 equals 6x plus 61. Subtract 6x, put our x's together, 4x plus 17 equals 61. Subtract 17 from both sides, 4x equals 44. Divide by 4, and we get x equals 11. Now we're asked to find the measure of angle R. R is 21 plus 6x. So we're going to go and we're going to add in that 11 instead of the x. So we get 21 plus 66, which is 87, and that's the measure of angle R. So we solve for x, plug x back in. Moving on, 110 outside angle equals sum of remote interior angles, 20x plus negative 2 plus 8x. So we get 110 equals 28x minus 2. I'm going to add 2 to both sides, so we get 112 equals 28x. that is going to allow us to get x equals 4. We know the measure of angle E is 20 times x. We go 20 times 4. Or the measure of angle E equals 20 times 4, or 80. Okay, UCB and measure of angle same thing. So UCB, we're going to go outside angle. 3 minus 4, negative 3 plus 14x equals 6x plus 85. Let's put our variables together. That's going to give us negative 3 plus 8x equals 85. Add 3, we get 8x equals 88. Divide both sides by 8, and we get x equals 11. We're looking for UCB. That's the outside angle. So we're going to go negative 3 times 14, or plus 14 times 11. It's going to go UCB equals negative 3 plus 154. I want to double check that. 14 times 11, yeah, 154. So that gives us 151, actually. I put 152, and that is wrong. I'm going to go change that right this very moment. 151. Okay. So, moving on. Measure of angle S, 96 equals 5x plus 17 plus 4x minus 2. That's going to end up, so what we did there, I just kind of rushed, is 96 equals 9x plus 15. Okay, so that's 5x plus 4x equals 9x. 17 minus 2 is 15. So we're going to add 15 to both sides. We get 81 equals 9x. We're going to divide by 9. That's going to give us 9 equals x. Okay, so then we have 5x plus 17, or 5 times 9 plus 17. It's going to give us 45 plus 17, or the measure of angle 5 equals 63. So next, state if the two triangles are congruent. If so, state how you know. So side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse, leg. Those are our 5 options. Now, whenever I see hypotenuse, leg, see, or whenever I see a right angle, I want to automatically try and determine whether or not hypotenuse, leg is a legitimate ability here. So for hypotenuse leg to work, you need a right angle with a congruent hypotenuse and a congruent leg. Here, right angle, congruent hypotenuse, congruent leg. Bingo. Yes, HL. That's it. Move on to 19 or 18. We have 2 sides there. And hey, check it out, vertical angles. So see how that angle is in between the 2 sides? That's important, because that allows us to do side, angle, side. If it was one of the other angles, not in between the 2 sides, we couldn't do it. Remember, no ass in geometry. 19. Okay, sides. You got 2 sides there. And then check it out, a 3rd side. We can call that, because that's for the reflexive property of congruency. We know this side is congruent to itself. So that gives us side, side, side. Here, again, now we know we have one right angle, and the other one forms a vertical pair. We know vertical angles are congruent, at least we should. And so that's going to give us 2 right triangles. Hypotenuse, leg, check, and check. So for the second time in 4 chances, we get yes, hypotenuse, leg. Moving on, 21. So here, now I like these 2, because they really show the difference between angle, side, angle, and angle, angle, side. 21. We have a side right there. We also have 2 sets of angles. Now, see here. See how it's angle, angle, and the side is not in between the 2 angles. Okay? It is a non-included side. Then on 22, we have 2 angles. And the side, see how the side is in between the 2 angles? That's how we know the difference between angle, angle, side right there. Boom, boom, boom. No side in between Here, yes, side in between. So we go yes, ASA. See how it's set up like that? Nifty. Okay, so that no right here, what I'm pointing at is if that side had not been in a corresponding position, it would not have been congruent. In order for AAS to work, it needs to be two sides and two angles, and the non-corresponding side. Okay, so that was 25%, or a little over 25% done. Okay. Onward and upward. 23 and 24. Angle, side, angle, 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 side. Now we look. Is that side in between the two angles? No, it is not. So we say yes by angle, angle, side. Same thing here. See how that side is not in between the two congruent angles. So we also say yes by angle, angle, side. Okay. So on all of these next ones, 25 through whatever, we're going to go, so we start at that 114. And we need to get to x. So we're going to talk about how we do that. So here, now all of these are called isosceles triangle or equilateral triangle problems. So all of these are going to have at least one, if not several, isosceles triangles in them. An isosceles triangle, as we know, allows us to use the isosceles triangle theorem or the converse of the isosceles triangle theorem. The isosceles triangle theorem says that if two sides in a triangle are congruent, then the two opposite angles are congruent. The converse of that, remember converse is flipping the if and the then. Two angles in a triangle are congruent, then the two sides opposite must also be congruent. Okay, I think all of these deal with the actual isosceles triangle theorem, not the converse. But anyway, so we have 114 there. So I'm going to label both of those y. So then I'm going to use the triangle angle sum theorem. That is that all triangles have interior angles that add up to 180. And we're going to go 2y plus 114 equals 180. Now we're going to solve for y. And we're going to get y equals 33. So that angle right there is 33. Well, how does that help us? Well, that angle right there is a pair, a vertical pair, so congruent to that angle. So that gives us 33. That 33 is an angle in another congruent or isosceles triangle. And here, since we know those two sides are the same, we know that the angles opposite are the same. So we get x equals 33. Now the first couple we're just going to solve for x. The latter few we need to solve for x and then plug it back in. Okay. So we have 25. So we have 55 there, right? So we know that 55 plus y got to add up to 180. So that gives us 2 times 55 equals 180. 110 plus y equals 180. Or y equals 70. Okay? So we know that's 70, we know that's 70, and just like number 25, since it's an isosceles triangle, that is 70 as well. So you go x equals 70 degrees. Here, this is a little bit trickier. Okay? So it's still an isosceles triangle. So we know that if one of them is 48, the other one's 48. But here, that 48 is part of a right angle. Okay? So we know that 48 and the other one are complementary. So we go, what is x? So we go 48 plus x equals 90. So we subtract 48 from both sides, and we get x equals 42. Now here, starting with 28, we have a couple where we're actually going to have to use that x once we find it. Or no, in order to find x, we need to use the angle measure. So we start off with 77 and 77, okay? So that is then going to give us that little angle down there. So we know that 2 times 77 plus y equals 180. That's going to give us 154 plus y equals 180. it's going to give us y equals 26. So if that's 26, we know that, I'm going to name that other angle z. 26 plus z equals 90. So z equals 64. So here, we know that that's 64. And this is where it gets tricky. So now for the first time, we're not, in all the other ones, we found the base angle. So here, we're given the vertex angle. That's the non-congruent one. So we know that what's going to happen is that if 64 plus 2 times the measure of angle 2 is going to be 180. So then we just need to solve for the measure of angle 2, and by doing so we get the measure of angle 2 equals 58 degrees. Almost there. 58 equals 9x minus 5. Add 5, divide by 9, and we get x equals 7. More of the same here, 29 and 30. So we start off with 55. We know the other one's 55. 2 times 55 plus y equals 180. You can name him anything. You can name him, Z, W, Blue, Patty, I don't care. So we have 110 plus y equals 180. So then we get y equals 70. So if y equals 70 there, then that one also equals 70. Because that 70 is one of the base angles in the isosceles triangle, means the measure of angle 2 equals 70. So I plug in 70 right there. I get 70 equals 77 plus x, or x equals negative 7. Again, it's okay for x to be negative as long as the angle isn't. So here we need to use complementary angles again. So we go 32 plus y equals 90, y equals 58. The other one equals 58, so we need to go back up and go 2 times 58 plus the measure of angle 2 equals, nope, snakes, damn it, sorry. Let's back up there a little bit. So 2 times 58 plus the measure of angle 2 equals 180. Oh, she erased everything. Good job, snake. 116 plus the measure of angle 2 equals 180. The measure of angle 2 then equals 64. 64 equals 8x plus 8. Subtract 8 from both sides, we get 56 plus 8x, or x equals 7. Okay, so now 31, starting at 31, these are the triangle midsegment theorems. These are the ones we went over at the beginning of last week. So they are either going to be the hardest for you because we have practiced the least with them, or the easiest for you because we just went over them. So the triangle midsegment theorem says this, that if you connect 2 midpoints of a triangle, then the segment that you get, the one that you just created by connecting those 2 midpoints, is going to be parallel to the third side. Because if it's connecting 2 sides, it's not touching the third one. And not only is it not touching the third one, it will never touch that line containing the third one. They are parallel. Not only that, it's exactly half its length. So, this is what we do. We either go WY equals 2 times PQ, or PQ equals half of WY. I personally like the top one. Why? Because then I'm not multiplying by fractions. And as much as I can multiply by fractions, I prefer it not to. Okay. So we know that WY equals 2 times PQ. So again, another way to remember this is when you have a problem like this. And how do I know it's a problem like this? Because I have this line right here, this line right here, and I've also got these. When I have those, that says that Q and P are halfway points or midpoints, and that means I'm going to want to use the mid-segment theorem. So I'm going to go 2 times x plus 1 equals x plus 10. That gives me x plus 10 equals 2x plus 2. That's going to give me 10 equals x plus 2 subtracted x, or x equals 8. Now I can plug that into PQ and get PQ equals 9. To make sure I did it right, I might want to go back up and do 8 plus 10 and get 18 and go, hey, 9 is in fact half of 18. Okay, So moving on. 2 times x plus 15 equals x plus 22. 2 times the short equals the large. That's how I like to remember it, more than the long. Okay? 2x plus 30 equals x plus 22. Subtract x from both sides. I get x plus 30 equals 22. Subtract x from both, or 30 from both sides, and I get x equals 8. Now here, because I got a negative, I'm absolutely going to check my work. I know I told you at the beginning, we get zeros, we get negatives all the time, but just like you, they still make me a little uneasy. So what I like to do is when I get them, go back, check my work, make sure I did it right. So I have negative 8 plus 22 is 14, negative 8 plus 15 is 7. Let me go back really quickly. That was me, not the snake. Km equals 7. Moving on. So again, 33, 34, same thing. I'm still going to explain it, but if you need to, go back. And I did a video on this. It's called Wonders of Wonders, the Triangle Mid-Segment Theorem. I know that because it's about the triangle mid-segment theorem, and I tend not to give my, dragon fireball unicorn as the name of my video when it's about not, dragons, fireballs, and unicorns. Anyway, 2 times the short, 2 times 3 plus x equals the long, 4x minus 6. 6 plus 2x equals 4x minus 6. It's going to give me 2x minus 6 equals 6. Add 6, I get 12 equals 2x. Divide by 2, I get x equals 6. I'm looking for QS, so I go 4 times 6 minus 6, and I get 24 minus 6, or 18. Quick check, 3 plus 6 is 9. 9 is indeed half of 18, so I know I did it right. Okay? 2 times the short, 2 times x plus 21 equals the long, x plus 33. 2x plus 42 equals x plus 33. 2x plus 42. So I subtract x from both sides. I get x plus 42 equals 33, or x equals negative 9. Again, want to double check that. Negative 9 plus 21 gives me 12. Negative 9 plus 33 gives me 24. So I want to check that, make sure, because even though we do get negatives a lot, still like to make sure. Okay. BC, we're looking for, so we go 2 times the short, that's the BC we're looking for, equals the long, x plus 16. 34 plus 4x equals x plus 16. I'm going to subtract my x's to join up my variables. 34 plus 3x equals 16. Subtract 34 from both sides, and I get 3x equals negative 18. It's going to be x equals negative 6. I'm looking for BC, so I'm going to go 17 plus 2 times negative 6, 17 minus 12, or 5. Now again, I want to go back. I can check that there. Negative 6 plus 16 is 10. 5 times 2 is 10. Check. 2 times the short. 2 times x plus 15 equals the long, x plus 23. 2x plus 30 equals x plus 23. Subtract my x, I get x plus 30 equals 23. Subtract 30, and I get x equals negative 7. Plug it in, I get tu equals 8. I'd get h, whatever is on the other side of that. 23 minus 7 is 16. So again, I have that 2-to-1 relationship. 8 times 2 is 16, so I know I did it right. So I may have paused it at some point. If I did, please email me and tell me what you guys missed. Because that sucks. I don't know. I'll have to go back and watch it once it's done. Anyway. So we get here, our midpoint is 2.5, 1.5. So if I did miss something, then I've just been sitting here talking to myself for the past 20 minutes. Anyway. For our endpoint, we're going to go x2 equals 2xm minus x sub 1. That's y2 equals 2y sub m minus y sub 1. x1, y1, xm, ym. So we just plug them in. our second midpoint, our endpoint, is equal to 2 times the midpoint minus the first endpoint. So x2 equals 14. Plug it in, same thing for y. 2 times our y midpoint minus our y endpoint. So we get a midpoint of, or the second endpoint is 14, negative 6. x1, y1, xm, ym, plug it in. x2 equals 2 times our x midpoint, negative 8, minus our x endpoint, negative 2. Get negative 16 plus 2, x2 equals negative 14, y2 equals 2 times negative 6 minus a negative 10 or negative 12 plus 10 or negative 2. So our second endpoint there is negative 14, negative 2. All of these triangle angle sum theorems. It's important, that's why we're kind of doing it again and again and again. So 65 plus x plus 55 plus 70 equals 180. We get x plus 190 equals 180, or x equals negative 10. 63, 70 plus 50 plus x plus 61 equals 180. X plus 181 equals 180. X equals negative 1. 70 plus 4x equals 180. 140 plus 4x equals 180. 4x equals 140. And x equals 10. 70 plus 74x plus 1 plus 35 equals 180. 74x plus 106 equals 180. 74x equals 74. And x equals positive 1. No, I did not intend for it to be negative 10, positive 10, negative 1, positive 1. That's just kind of how it worked out. Okay, now 66, where it's saying that we need to figure out what piece of information is missing. Okay. Now it's important that we sit there and we look at this and go, okay, well, what is it they're asking us? And what do we need to make that come true? It's not enough just to say, hey, listen, there are two sides. If we have a third, so look at 66. 66, a lot of you guys on the chapter test would sit there and go, oh, we want IG to be congruent to XV. And you know what? Yeah, that would tell me the two triangles are congruent, but that's not the question. The question is, given my two sides, what would make it side angle side congruency? And that's my angle, because I have my sides already. And see, side angle side, side angle side. If I sit there and go, well, XV or IG are congruent, then that would be side, side, side. I also just can't randomly pick an angle. It has to be the angle in between the two. Here, AAS, okay? Now here you have two options because, well, we do. They just can't be... so we have H is congruent to Y or G is congruent to X. They need to be in that order, though. You can't flip them around. 68, ASA. Okay? So that's angle, side, angle. Now they give us one angle. We can figure out that the second one is there because of vertical angles. So when we're looking here and we have our angles, that S has got to be in between the two, okay? It just can't be a random side. Look at the actual words. It's got to be between the two. So we need IW to be congruent to WV. Same thing here, ASA. Side's got to be between the two angles. So CD has to be congruent to HD. Now, in all fairness, we could sit there and say, well, if XW was congruent to WK, they'd also be congruent. And they would, excuse me, but then I'd be proving congruency by angle, angle, side, not angle, side, angle. The problem requests angle, side, angle. We give it angle, side, angle. Okay. Some more of these little tricky ones. We're looking for the value of x. So on all of these, we figure out the measure of angle 2 and then go from there. Okay, these are tough. I like these because they ask you to put together a lot of different things. So starting at 144, that means that that angle right there, y, is 180 equals y plus 144. It's going to be 36 equals y, not x. So we know that isosceles triangles have similar base angles. So that means if one of them is 36, the other one's 36. Notice that those are the angles opposite the congruent sides. That 36 up top is part of a complementary pair. Okay, complementary means it adds up to 90 degrees. Okay, so that's going to give us 36 plus whatever that other one is equals 90. 36 plus, I think I call it z. Yep. So that's going to go z equals 54. If that equals 54, that equals 54. So we know that 2 times 54 plus the measure of angle 2 equals 180. That gives us 108. Plus the measure of angle 2 equals 180, or that 72 equals the measure of angle 2. Plug it in, and now we can finally solve for x. 84 equals 6x, or 6 equals, or not 6 equals, 6 equals itself. X equals 14. So remember, we have to go from 144 to angle 2, then use our measure of angle 2 to solve for x. Okay, next. Start with 63. We're going to go, that is 54. And again, we went 2 times 63 plus whatever's left over equals 180. That leftover turns out to be 54. It's a pair of vertical angles, so 54 and 54. 54 down there too. And again, we get that because of the isosceles triangle theorem. So 54 minus 68 from both sides, and we get x equals negative 14. Again, it's okay for x to be negative, just not the length of a side, length of a segment, or the measure of an angle. 72 and 73. That's 119, that's 69. That means they're both 69. 69, 69 add up to 138. 138 minus 180, or vice versa, is 42. 90 minus 42 is 48. If that's 48, that's 48. 48 and 48 is 96. 96 plus what equals 180? 84. So we know the measure of angle 2 is 84. 84 equals negative 7 plus 7x. We're going to add 7 to both sides. And we get 13 equals x. Okay, add 7, we get 91. 91 divided by 7 is 13. 73. If one base angle of an isosceles triangle is 68, they both are. 68 plus 68 is 136. 180 minus 136 is 44. Both of those are complementary angles. 90 minus 44, 46. 46 base angle. Other base angle, also 46. Here is a new one. It is an exterior angle, which means it is going to be supplementary to that interior angle right next to it. 180 minus 46, 134. Plug that in for the measure of angle 2. 134 equals 10x minus 6. Add 6 to both sides. We get 140 equals 10x. 140 divided by 10 is 14. So 14 equals x. And yay, we're done. Okay, so we've gone over this a bunch. So I know I just kind of threw that all at you, but the hypothesis, Mr. Renard's geometry class, if you were in Mr. Renard's geometry class, the conclusion, then you attend Mingus Union High School. Okay? So we put that together as my hypothesis. That's if-then statement. If the hypothesis, then the conclusion. The converse, if you attend Mingus Union High School, then you attend Mr. Renard's geometry class. Inverse, we negate the original. If you are not Mr. Renard's geometry class, then you do not attend Mingus Union High School. And finally, the contrapositive. That is where we flip it. So instead of going if hypothesis, then conclusion, we go if conclusion, then hypothesis. And then we add it back in. Or we flip it and negate it, sorry. If you don't attend Mingus Union High School, then you do not attend Mr. Renard's geometry class. Truth value of each statement. The first two are false. The second one is true. Remember, something is either 100% true or it's false. So my counterexample, if you can give even one counterexample, it's false. My counterexample is seniors. I don't have any seniors in any of my 6 classes, so therefore, or everybody in my algebra class. I don't have anyone in my algebra class who's in my geometry class, okay? So, and they're all students at Mingus Union High School. So, moving on. Okay. Are these a good definition? The answer is yes. So how we do it, make sure it's a good definition, is we break it up into its hypothesis and its conclusion. We then write it as a conditional if-then, and then we write it as a... This is not going well. Okay, and then we write it as its converse. Now, if both the conditional and its converse are true, then it is a good definition and can be written as a biconditional. So here, I'm going to say yes, because I'm going to break it up. That's going to be its hypothesis, and that's going to be its conclusion. A linear pair of angles are angles which are both supplementary and adjacent. So let's look at it this way. If I said if a pair of angles are a linear pair, then they are supplementary and adjacent. 100% true. Flip it around. If a pair of angles are supplementary and adjacent, then they are a linear pair. Also 100% true. And that gives us a good definition, and we can then write it as a biconditional. The biconditional is a pair of angles are linear if and only if they're supplementary and adjacent. Okay, that if and only if, that's the important part to have in any biconditional. So, SAT is congruent to GRE, okay? Now what we're going to do is, sorry, I just got it. The SAT is the college entrance exam, the GRE is the grad school entrance exam. So, or one of them at least. So anyway, so that's supposed to be a joke. So what we want to do is just match each one up with the opposite letter or letters on the other one. So S is to G, GR, SA, E is to T, RE, AT, TAS, EG to TS, REG, ATS, R is to A. If you don't understand any of that, come and see me. Basically what we're doing is we're looking at this statement right here and and matching up the letters. Okay, complete the following proof. Okay, now I'm going to do this one as a 2-column. I'm going to slow it down a little bit. So left, steps, right, reasons. I'm going to speed it up a little bit. Okay, so I'm going to start off with my givens. OTS is congruent to OES. That's given. And EOS is congruent to OST. Also given. Okay, we also know that OS is congruent to OS. And that is when something is congruent to itself, the reflexive property of congruency. Finally, we have TSO is congruent to triangle EOS. Now we can say that because of what we just did. We started off with 2 angles. We knew that that side right here is congruent to itself. And so now we have 2 triangles with 2 congruent angles and a non-included side. So that's AAS. I just hit the wrong button. I was supposed to keep playing, but anyway. And once we can say that TSO is congruent to EOS, we can say that TO is congruent to ES by corresponding parts of congruent triangles are themselves congruent. CP, CTC. Fill in the blanks. We've done this one before, but we'll do it again. It's okay. So it is given that RT is congruent to SU. And if you don't know what they're talking about, you can read so blank and blank are blank angles because perpendicular lines form blank angles. Well, I know that perpendicular lines form blank angles. So I'm looking here and going, okay, well, what 2 angles are going to be right angles? Perpendicular lines do not form blank angles, they form right angles. So I go, well, RTS and RTU are right angles because perpendicular lines form right angles. RT is congruent to RT by the reflexive property of congruence. Now again, when I sit there and look at it and go, okay, the reflexive property of congruence, what up there could be reflexive? And RT is the only one. It is given that RU is congruent to RS, so RUT is congruent to RST by hypotenuse leg. Look at what it was that we proved. We proved that we have 2 right triangles. We proved that their hypotenuses are the same. That was given. And we proved that one of their legs was the same by the reflexive property of congruence. Hypotenuse leg. And ladies and gentlemen, that's it in under an hour. So exciting. Good luck.